All right, flip back to your front page for right now. I want to talk about the chapter in general and then our learning targets for today. So you'll see that our chapter 3 is on simplifying and solving. We're going to really focus on exponents for the first 3 lessons. You can see we got exponents, exponents, and exponents. The first half of this is going to be exponents. Normally we do this only in 2 lessons. We're stretching it out to 3 lessons. And I'll tell you why right up front. Is because my students in the past have really, really struggled with exponents. Okay, it's not that it's hard. They don't have a hard time understanding it. They have a hard time keeping it all straight. There's lots of different rules, and they have a hard time remembering when do I use this rule and when do I use this rule. That's the difficult thing. So we're going to go through a little bit slower this time, but I want you to just keep that in the back of your mind, especially with what we're going to do today, is the difficult thing is not going to be how to do these problems. You're going to find that easy. The thing that's going to be challenging for you is remembering when do I do this and when do I do this, okay? We're going to do 2 different things today. I need you to be able to differentiate when do I use each one of them. Now, that's today. We're going to add 2 more things on this day, and then we're going to add 2 more things on this day. So you're going to have 6 things you got to keep straight. And that's where my students struggle, is they're not doing the work they need to make sure they remember when to do what. And I'll give you some hints about that, but ultimately that's up to you to do what you need to do to memorize those things. Flashcards, make lists, make a vocabulary list, make an example sheet. Do what you got to do so that you can remember when do I use these different rules. Okay, so that's my preface for today. This is the 15th. We're starting here. And let's talk about our warm-up problem first. I just asked you a simple question, yes or no. Does it matter what order we multiply numbers? Yes or no? Give me a thumbs up for yes, thumbs down for no. Does it matter what order I multiply numbers in? I'm seeing a little bit of both. Can somebody give me an example to justify? Does anybody want to volunteer to give me an example? Give me an example of 2 numbers that we could multiply. Can you make them a little simpler so that we can do them in our head? 10, I like 10. 10 times 13. Do you guys know what 10 times 13 is? It's 130. If I switch those around and multiply the 13 times the 10, so if I reverse the order, does that change the answer? It's still 130? So it seems like for that example, it doesn't matter. Can somebody give me 2 more numbers that we could multiply in our heads? What do you got? Sure. -5 times -2. Now when we multiply a negative times a negative, we're going to get a positive answer. 5 times 2 is 10. If I switch the order and do -2 times -5, does that change my answer? It does not. So does it matter what order we multiply things in? No, it does not matter. You can multiply in any order, you're going to get the same answer. Okay? I need you guys to remember that because we are going to be multiplying a bunch of stuff today. And sometimes we're going to do it in different order, but we know that's okay. We can do it in any order that we want to, okay? All right, let's talk about shortcuts. Mathematicians hate writing out a bunch of long stuff. I am going to force you to write out a bunch of long stuff today, and some of you are going to get really angry with me, but that's okay. You can handle it, okay? And then I'm going to show you some shortcuts. Move back to your assigned seat right now. Assigned seat. No, you can stay. Eric, go back to the back row there. All right. Some of these you already know. Like, for example, if I wanted to add up a bunch of x's, I don't want to have to write this down every time. There's a shorter way to write this. What could I write instead of x plus 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 x? I could just write that as 7x. Somebody decided a long time ago, if I was adding a bunch of the same things together, we could just put the number of things in front of it, and that would mean add a bunch of stuff. That's what 7x means. We call that 7 a coefficient. It is a coefficient. And what a coefficient means is whatever that number is, that's how many times we're going to add that thing together. So 7x literally means take 7 copies of x and add them together. There's another symbol that we use when we're multiplying a whole bunch of stuff. Do you guys know what that is? we'd still have an x, but we'd put the number of x's not out in front. Where do we put it this time? In the exponent. This is also 7x's. That's time they're being multiplied together, so this time we would put that 7 up there as an exponent. So when we're multiplying a bunch of things together, we use an exponent so that we don't have to keep writing them out over and over and over again. Just makes things way, way simpler. By the way, that's the exponent right here. And then the big thing on the bottom is called the base. You'll hear us refer to those bases today, and when we do our work next Tuesday and Thursday as well. So exponent and base. The exponent tells you how many times to multiply that base. So let's do a couple of problems. Could I get you guys to just focus on 1 through 10? If you finish these, do not move on. Okay? Let me be very clear. Do not move past 10. If you're not sure what to do, I'll kind of walk you through a couple of them here. We'll do number 1 together. I'm multiplying a bunch of stuff together. The thing I'm multiplying together is x. How many copies of x am I multiplying together? 4. I'll do number 3 with you also. This time I'm multiplying 2 different things. I have x's and y, so I'm going to write an x and a y. We'll put exponents on both of them because we have multiple copies of both. How many x's are there being multiplied together in number 3? 4 x's. 1, 2, 3, 4. How many copies of y am I multiplying together in this one? There's 6 there, so x to the 4th, y to the 6th. By the way, does it matter what order I put those in? Could I have put my y to the 6th first and my x to the 4th second? We can, because it doesn't matter what order we multiply in. Usually I'll do alphabetical order, but it actually doesn't matter. All right, you guys work through the rest of those. Let me know if you have any questions. We'll go over answers here in a moment. I'm going to give you about 2 or 3 minutes to work on those, and we'll move on. All right, can I get you to pause wherever you're at right now? If you're finished, I want you to check your answers against mine. I want to talk about 8, 9, and 10 because those ones are a little bit trickier. So if you haven't gotten to those, please work through those with me. Can you pick your head up off your desk, please? Do you need to go to the nurse's office? Are you feeling okay? Okay. All right, and number 8, it may be tempting to think of this 2 and this x as stuck together, but they're just being multiplied, right? You guys know when you see a 2 with an x next to each other that it's being multiplied. So they're not really stuck together. We could rearrange this whole thing and put those 2's first and then those x's afterwards. And it would be the exact same thing. We're allowed to multiply in any order we want to. So I usually probably wouldn't do this step. I would just go through and count and say I've got 1, 2, 3 2's being multiplied together. So there's my 3 2's. And then I got 1, 2, 3, 4 x's being multiplied together. So x to the 4th. All right, if you made a mistake on number 8, please fix that. Looking at number 9, I know when I look at this that I see the 4 x's. I know I'm going to have an x to the 4th in my final answer. The question is, what do we do with this 3 and this 2 and this 5? There's no repetition there, so we're not going to get any exponents there. My answer to you is we would just multiply those together. What is 3 times 2 times 5? 3 times 2 is 6. 6 times 5 is 30. So a final answer there would be 30x to the 4th. Let's look at this last one together. Let's do it the same way. Focus on your coefficients. You've got 5 times 3 times 2 times 4. Now, if you can't do that in your head, grab your calculator. 5 times 3 times 2 times 4 is, I want to say, 3 times 4 is 12. 2 times 5 is 10. 10 times 12 is 120. 120 for my coefficients. And then I got some x's. How many x's? 1, 2, 3, 4, 5 x's. And then how many y's? 1, 2, just 2 y's. And that would be my final answer there. Please check over and make sure that your answers match mine, and then we are going to fix a couple of these because I have a couple that can be simplified further. Does anybody have any questions before we fix these? Okay. Let's fix number 5 and number 6 and number 7 and number 8. Because anytime you have a number with an exponent on it, we can simplify that. 2 to the 5th power, we can simplify. That's 2 times 2 times 2 times 2 times 2. Do you think you could do that in your head? I'm going to count while you go. What's 2 times 2? 4 times another 2 is 8 times another 2 is, what's 8 times 2? 16 times another 2 is, 16 times 2 is 32. Now let's check with the calculator. I want to make sure that everybody knows how to do an exponent on their calculator right now. There's a lot of different styles of calculators out there. But what you're looking for, well, first of all, go ahead and type in your 2 in your calculator. You have yours with you? Come on, guys, let's get our materials out. The button you're looking for in your calculator to do an exponent on most of your calculators is going to be this one here. It's got a little upside down V. When you hit that button, you're going to get that little upside down V, and then your exponent goes after that. So that means 2 to the 5th, and when I hit enter, I get 32. Did you guys find the upside down V on yours? Some of your calculators are a little different. Are you seeing an upside down V on your calculator? Yours is actually, it's this one here. So I think if you go 2, 5, there it is. So that number, this, and then your exponent. Okay. Did you get 32 to show up on yours? Can I put this up on the screen? This is a really common. I think this is going to be the same as yours was just a second ago, so you guys can kind of remind each other. I believe it's going to be this one here with the x and the y with the exponents, and I think you do the base first. So our base was 2, and then that number, and then the exponent 5, and then hit enter, and that gives you your answer. So you're going to use this button here. It's the big number on the bottom, that button, and then the exponent. Were you guys able to get, where's your calculator? You guys able to get 32 to come up? Yes? Okay, awesome. So can you guys go ahead and fix the other ones? This is 2 to the 3rd times x to the 4th. What is 2 to the 3rd power? Oh, I'll come over and help you in a second here. 2 to the 3rd is 8, so your final answer would be 8x to the 4th. Can you please fix number 7 and number 8 for me too, please? Yours is, may I see, I think it's this one here. So if you hit that, yeah, that gives you the little thing, and then you'll put your 5 in there. So this is this one here, and there's your 32. So it's that one with the little x with the little box where the exponent is. That's going to get you an exponent. All right, this one says 2 to the 4th, 2 to the 4th. I think I know that one. It's 16. And this is 2 to the 3rd, which is 8. All right. Questions so far? Okay. Folks, we are heading into the most annoying part of this lesson, but we're going to do a quick test period, okay? I am going to challenge you to do as many as you can, but I'm going to limit your time. I'm going to tell you that you will not be able to finish all the problems in the time that I give you, but I need you paying very, very close attention right now while I go over the first 2 on here. Okay, I asked you not to move ahead because I'm going to ask you to do some very specific steps here. So please pay attention. Did you have a question about your calculator? Can you stop messing with it then and pay attention, please? I don't want you to miss this. There are 2 things you're going to do here. You are going to expand and you are going to simplify. You must do both. Now, some of you are going to find some shortcuts, and you're going to say, I don't need to do this expand step. I can just simplify and know what my answer is going to be. We are going to do that on the back, but we're not going to do that on this page. Can you move back to the seat you were sitting in a moment ago? All right, so let me show you how this works. For this number 11, this says that we're going to have how many copies of x here? It says 3 copies of x. So write me down 3 copies of x. You don't need to put dots in between them. Just write them down. X, X, X. I need everybody writing down on their paper right now. There's my 3 copies of x. And then times, you can put a dot if you want. You don't need it. We're just going to put them right next to each other. There's 2 more copies of x there. So there's 3x times 2 x's. All right, and then we're going to simplify it. So write equals. And let's write that as x to a power. How many x's are there altogether there? 5. I want everybody to do number 13 and then stop, please. Please do number 13 and then stop. Follow those same steps. Make sure you're writing out 5 copies of x. And then 3 copies of x. Equals, and then your final answer. How many people think they already know what the shortcut is for this thing? All right, we'll do it. A couple of you do, but I'm still going to have you write them out. Now, let's do 12 and 14 together also. Folks, are you with me? Please pay attention. For number 12, this is 3 copies of x, but I need to make 2 copies of those 3 copies. Right? This little 2 on the outside says we need 2 copies of everything inside the parenthesis. So there's 3 copies, and then there's my second 3 x's. So my 2 here is giving me 2 copies of those 3 x's. When all is said and done, how many x's do we end up with? 6. Let's see if we can do the same thing for number 14. So I'm going to make 5 copies of x, but I need to do that 3 times. Guys, we're not supposed to eat in here. It's food allergies and all that stuff. Thank you. Appreciate it. 1, 2, 3, 4, 5. That's my first copy. 1, 2, 3, 4, 5. There's my second copy. 1, 2, 3, 4, 5. There's my third copy. And then we'll count up how many x's we got there altogether. That is, I think that's 15 copies of x. All right, I would like you to continue working down through these. Again, I am not going to give you enough time to finish all of these. Your goal should be to at least get up to number 20. If you get through 20, keep going. Try some of the tougher ones. I'll put answers up on the screen in a moment, and I'll be around to answer questions. So on these ones where you have like coefficients, those big numbers, the way I tackle these is usually I will look at those coefficients and I'll put those at the front. 2 times 3 times 4. And then I'll go through and I'll count up my x's. Here's 1. There's another 2 here. And another 3 here. And then I'll go through and look at my y's. There's 1 here. I'm just going to put it down underneath because I'm running out of room. And then another 4 here. 2, 3, 4. And another 2 at the end. And now I've got everything I need to write my final answer. 2 times 3 is 6, times 4 is 24. There are 6 x's there. There are 1, 2, 3, 4, 5, 6, 7 y's. All right, I'm going to put the answers up here. And while you're looking over these, I just want to thank you for being patient with me. I know that some of you are very annoyed with me, or maybe with math, hopefully you're not taking it personally, that you had to write out so many x's and y's. Now, if you didn't get to all these, that's okay. I'm not interested right now in you copying down answers. Just check the ones that you did, okay? Don't try and copy the rest of these down. You don't need to have every single one of these down. If you've got up through number 20 done, that's enough for you to be successful with where we're going next. Okay, so don't waste your time copying down answers. Check the ones that you did. See if you made any mistakes, and if you did, that's okay. This is the first time we've done this. Does anybody have any questions on these before we move on? All right. This whole expand thing is annoying. How many people agree with that? The part in purple up here, having to write them all out. Okay, I got good news and bad news for you. Which news do you want first? The good news or the bad news? Bad news first. Okay, on your assignment today, I am going to give you 4 problems where you have to expand them and then write down the final answer. That's the bad news. Okay, you want the good news now? There's 2 pieces of good news. One of them is there's only 4 problems, and they're a lot shorter than these ones. And the second piece of good news is there's going to be 4 other exponent problems, but you don't have to expand them. You can just jump straight to the final answer. Okay, because that's where we're eventually going. Now, I want you to practice expanding, and I'll tell you why at the end of class. But for right now, let's talk about shortcuts. Once again, I need everybody to stop copying down answers and doing problems. Actually, if I could just get you to set your pencils down right now so that I can see that your pencil's on your desk and that you're paying attention up on the screen. Could you guys please put your pencils down? Can I see eyes up pointed towards the screen, please? Thank you so much. This is the key part of our lesson right now, okay? Don't miss this. Hopefully nobody's in the bathroom. One person is. Oh, they're going to regret it. This is the part that's going to make your life easier. Could you please put your pencil down and pay attention, okay? Thank you. I appreciate that you're keeping after it, but this is more important than you finishing that, okay? All right, here's the deal. There is a shortcut. We don't have to write down all these x's. Some of you figured out what it is. How could I have figured out that this answer was 5 just by looking at those two exponents? What do you do with a 2 and a 3 to get 5? You add them together. Now is it always add? What about this one? This one had a 6. Did we add 2 plus 3 to get 6? Ooh, this one we multiplied. Now, how am I going to know whether I add or multiply? So if you look at these problems, the way I set this up, all of these problems kind of look the same. They don't have parentheses with an exponent on the inside or outside, right? These ones all have the parentheses. We call these product problems because we're multiplying things together. You don't need to write that down. Leave those pencils down. We're going to take notes on this in just a second, okay? So just pay attention. Relax and pay attention. We call this power to a power. Power to a power means you have a parenthesis with a power on the inside and a power on the outside. And the shortcut is, if it's a product problem, you just add. 5 plus 3 is 8. 2 plus 4 is 6. Now this one was kind of tricky. Could I get you to pick up your pencil right now and stick a 1 onto this x? That exponent of 1 was not on there, was it? Usually it's not written, but just like coefficients, if there's not an exponent, there's an invisible 1 on there. Okay, so 3 plus 1, that's where we got our 4. Look down at this at number 21. There's x's and y's. If you focus on the x's, you see 3 and 2. That's where I got 5 from. If you focus on the y's, you see 4 and 5. That's where the 9 came from. So we add in that situation. In a power to power, we multiply. 5 times 3 is 15. 2 times 4 is 8. 3 times 2 is 6. Now this 25, we're going to talk about how to deal with that in a minute, okay? So let's flip over on the next page. Pick up those pencils. Let's take some notes on this. Shortcuts. We love shortcuts. We don't have to write out so much. So remind me, in this situation, are we adding or are we multiplying? We are adding. And in our notes here, let's write this as x to the a plus b. And let's come up with a really nice example here. Someone give me a couple exponents, something that we would be able to add in our heads. Can you give me a couple numbers? 2 and 4. That is an excellent example. Very nicely done. X to the second times x to the 4. If we use this shortcut, our answer is going to be x to the 6th. 2 plus 4 is 6. And we didn't have to write them out. That's way better, isn't it? Now, if there's a parentheses with the power on the inside and outside, that's our power to a power situation. In this case, we don't add, we multiply. So if it was A and B, we would do A times B. Should we use that 2 and 4 again? Why not? Why not? Let's set it up, but we're gonna use it in a different situation. This time we've got parentheses. So we'll have x with a 2 on the inside and a 4 on the outside. And this time our answer is not x to the 6th, it's x to the 8th. 2 times 4 is 8. This last little box here is just about invisible exponents. If I give you something that does not have an exponent on it, I need you to know that the exponent is 1. So if you see an x, you can always put a power of 1 on it. When a base has no power written, the exponent is 1. So if I had a y, that's the same as y to the 1. If I had an a, that's the same as a to the 1. Now this also works with numbers. If I had a 5, 5 is 5 to the first power. Everything has an exponent. A lot of times I am going to write these ones in. You guys are going to see me do that as we work through a couple examples here, okay? So I'm going to do a couple of these down here with you, and then you're going to do the rest, and then we'll be done. Okay? Does anybody have any questions? So it'd be a great time to be here and get a couple examples if you can. It's up to you though. Okay. Here we go. So number 27. I see a 7 and a 3. I know my answer is going to have, it's either going to be 7 plus 3 or 7 times 3 for my exponent. Is this a situation where we add or where we multiply? This looks like power to a power to me, doesn't it? So that would be multiplication. 7 times 3 is 21. Look at that. Isn't that much better now that we don't have to write out all those x's? Way better. What about a number 28? So 7 and a 3 again. Should we multiply them again? Is this a situation where we add exponents or multiply? This is one where we add. Okay, folks, I'm hearing, when I'm asking these questions, I'm hearing 1 or 2 people answering me. Remember what I told you at the beginning of class. This stuff is not hard. The hard part is going to be you remembering when do I add and when do I multiply. If you are not practicing that and saying it in your head every time you do it, you're going to forget it, okay? I can tell you this for a fact because last year on the exponents part, people bombed it. They got 50% because half of the time they couldn't remember if it was add or multiply. Now it seems easy to you right now, but I'm going to tell you in 4 weeks, you're going to forget when do I add and when do I multiply unless you're really practicing this as you do it. One way to do that is either to say it out loud or kind of say it in your head, okay? So for this next one, I'm going to ask the question, and before you write down an answer, I want you to say the answer in your head. Is this a situation where I add, or is it a situation where I multiply? Well, we're all saying add in our head? I hope so. Now, what am I adding? Ooh, there's an invisible exponent. I better get down on my paper. Could you guys all fill in the invisible exponent that's in this problem? Stick that invisible 1 on that y, and we're going to add up all of those exponents. What do I get when I add up 4 plus 8 plus 1? 13. Anybody want to guess what, if I put this on a test, what do you think the most common wrong answer would be? Y to the 12, because people are going to forget that there's a 1 on that Y. All right, let's look at this next one. Add or multiply? Multiply. It's got the parentheses, so we're going to multiply. Anybody know what 3 times 15 is? It is 45. Folks, I'm going to have you skip down with me to number 35. Please stop wherever you're at. If you're working ahead, that's fine. Please skip down to number 35. We're going to deal with this one piece at a time. Let's start with the 2 times 10. Can you do that in your head? 2 times 10 is 20. And then we got some x's. So write down an x. Now what am I going to do with my exponents here? Am I going to add these exponents or am I going to multiply them, the 2 and the 3? I'm sorry, the 4 and the 3. We should add, there's no parentheses here, so we're going to add the exponents. 4 plus 3 is 7. And then focus on the y's. 2 and 8, you said we were going to add before, so we'll be adding these also. 2 plus 8 is not 8. 2 plus 8 is 10. All right, one more. Please do one more with me. Let's look at 38. Please don't miss this one. This is one that a lot of people are going to miss, this style of problem. There are 2 things in this problem that do not have exponents. Can you please put an exponent of 1 on both of the bases that are missing exponents? I'm sure you're seeing one of them, but are you seeing both of them? Can I get you to please follow along with us? I like your tattoos, by the way. All right, we're looking at number 38 here. Do you see that both of the things that need a 1 on them? I bet most of you saw that M right away, but did you think that that 2 also needs a 1? Okay, now follow along with me because this is going to be a common mistake. Are we adding or are we multiplying the exponents this time? We got parentheses. When we have parentheses, do we add the exponents or multiply them? We're multiplying them. We multiply the exponents. That 2 does not get multiplied by anything. That 2 stays. It's the exponent on the 2 that gets multiplied. The exponent is 1. 1 times 3 is 3. And then we've got our m. M has an exponent of 1. Again, multiply it times the 3. 1 times 3 is 3. And then we've got our n. Multiply the exponents. 2 times 3 is 6. Now we've got this as a solid first step. We do need to go one more step on this because we can simplify 2 to the 3rd. What is 2 to the 3rd? What is 2 times 2 times 2? Spoiler alert, it is not 6. 6 is the most common wrong answer to that question. What is 2 times 2 times 2 is 8. If you were thinking 6, you were thinking 2 plus 2 plus 2, which is 6. 2 times 2 times 2 is 8. So the final answer is 8m to the 3rd n to the 6. All right. Same as before. Do as many of these as you can in the next, say, 2 or 3 minutes. I'll put answers up here so you can check. Please ask me some questions if you have questions. You do not need to finish all of these. If you can get down through 34, maybe 36, I would be feeling really great about your progress. Okay? So answers are up here. If it's possible, I've got mistakes on this. If anybody sees anything and you're like, I'm not sure that's right, could you please bring it to my attention so I can fix it? Once again, I am really not interested in you just copying my answers down right now. That's not going to be helpful to you. I'm going to make this go away in a second. As long as you got up through like 34 on here and you're feeling confident about those ones, then I am totally fine. If you got past there and you're still getting right answers on some of them, that's great. I'm expecting most people made some mistakes. Is anybody rocking a perfect paper on every single problem they did? Really? That's exceedingly rare. Okay? This is the first time we've done that. There's usually some mistakes. I made some mistakes when I made this answer key. Do you guys see any that you have any questions about? All right, so once again, please check your answers, but don't worry about just copying these down. That's okay. I have one more thing that I want to show you guys, and then we'll be done. I promised you that I would tell you why I'm making you multiply out all these things, okay? So let me just quickly show you on your assignment for today, the last two sets of problems are exponent problems, 306 and 307. Now, this is the good news, bad news from before. Remember, I said the bad news was on these four problems, I'm going to ask you to write out with all the x's and y's. Okay, I need you to write that out. I've given you some examples there in case you forget how to do that. But the good news is on 307, you do not have to. Now, can I please tell you why? And I hope that you guys will pay attention to this, because like I told you at the beginning, this exponent stuff is always the part that brings down my students' grade on test 3. Always. Every single year that I've taught Algebra 1. Okay, and I'm trying to get better at teaching you guys. And the one thing that I can't do is force you to do the work to kind of get stuff memorized. That's the problem with this. It's not difficult. What's going to be difficult for you in December when you're taking this test, and then again in February when you have to know it again for chapter 5, okay? What's going to be difficult then is for you to remember, when do I add and when do I multiply, right? Right now, if I gave you a problem like x to the 10th times x to the 5th, right now, I'm hoping that every one of you could tell me whether I add or multiply for this problem. X to the 10 times x to the 5th. Would I be adding that 10 and 5, or would I be multiplying them? You'd be adding them. And I can see the confidence on your face. You got to believe me on this. That confidence is going to go away. Okay? A month from now, you're going to look at this problem and you're going to be like, oh man, do I multiply or do I add? Okay? You just got to trust me on this. You're going to forget. Okay? So here is why I want you to know how to write it out. Can I get your attention up here, please? Let's say you get to this on the test. And you're like, I can't remember if I should multiply or I should add. I don't want you to write out 15 x's. Don't do that. Okay? Here's what you're going to do instead. Off to the side, you're going to make yourself a simpler problem. I like the 2, 3 problem. I always use 2 and 3 because they're nice small numbers. So off to the side, you're going to write x to the 2nd times x to the 3rd. And you're going to ask yourself, if I were to write this out, how many x's would I be writing down? 1, 2, 3, 4, 5. Agreed, there's 5 x's there. That's x to the 5th. That makes me pretty certain that I'm adding the 2 and 3, right? And if I'm adding the 2 and 3 here, then I'm probably going to add the 10 and the 5 here. Agreed? If I get to a problem like this on the test and it's x to the 20th times, or to the 4th power, is that x to the 24th or is that x to the 80th? Do I add or do I multiply? I can't quite remember. I'm going to do a 2, 3 problem. I know how to do this. I can write out x, but I need to do it 3 times. So there's xx, xx, and xx. And I look at that and I'm like, how many x's are there? There's 6. What did I do with 2 and 3 to get 6? Did I add or did I multiply? Ooh, I multiplied, right? And that makes me confident that I should multiply here as well. I want you to be able to do this as a backup for when you forget, not if you forget. When you forget. You are going to forget whether I should multiply or add. And I want you to be able to just make yourself a simple example and write out the x's and figure that out on your own. Okay, so if I can get you to practice that a little bit in some of our assignments, I'm going to give you 4 today. Next class, there will only be 2 where you got to write them all out. But I'm going to make you do it over and over and over again. My hope is that that's going to give you the tools you need to help you remember when you forget later on. Okay, that's my why. I promised I'd give you guys that. Okay, our goal for today was to simplify expressions with exponents that have power or power to a power. Do you guys feel like you met that learning goal today? All right. If you've got questions, we've got time. I'm going to come around and get you your assignment for you to get started on it. Thank you.